These are the notes for the set of 7.2. These notes are going to involve us creating 4 different constructions, and these were constructions that you did in the task. So this is a repetition of what you did with your class. So the first one is to construct a parallel line through a given point. So what that means is I want a line that is parallel to this line, but up here. So remember, parallel means they have the same slope. So some line that looks something like that. We wouldn't say that these 2 lines are parallel. And we want it to go through the point. So we wouldn't say, hey, look, these 2 lines are parallel and it's through the point. It's not through the point. It's above the point. So we're going to go back to our rhombuses. Rhombuses are really special. They allow us to construct all kinds of things. In this case, we can construct a rhombus, and that will allow us to get some parallel lines because the opposite sides of a rhombus are parallel. So the first thing I'm going to do to construct my rhombus is I'm going to finish off this length. I'm going to draw the line goes through here. And then I'm going to use the length from this corner up to the point as the length of my rhombus. So I've got 1 side, 2 sides, 3 sides, 4 sides. So again, in light pencil here, I'm going to fill in the rest of this rhombus so you can see where it is. So the rhombus is right here. But the part of this that I really care about is the part that is parallel to this line. And that is the line that is directly above. So now I'm going to go back and I'm going to do this in darker pen so that I am very clear about where my line is that's parallel. And then, depending upon what your teacher has taught you, they may have taught you that to indicate parallel, you put these tiny little arrows on the 2 lines. The next construction is for an equilateral triangle. You'll remember in the previous notes for section 7.2, we talked about the meaning of equilateral, which meant all 3 sides congruent. So I can measure this side, the side they give me, and then I can copy that measure just like we did with rhombuses. So I copy, I know that from this point where my stylus, where the pointy part of my compass is, to any point on this arc is going to be the same length as this given line segment. But I need a 3rd side, so I do that same process from the other side of my line segment. And where those 2 arcs intersect is where my 3rd corner, or vertex, of my triangle sits. And now I have an equilateral triangle. And so I can also mark this by the definition of an equilateral triangle, which is the 3 sides congruent. One of the big constructions that you did in this section was to construct a regular hexagon inscribed in a circle. When you did this, you explored the fact that a hexagon can be broken down into 6 equilateral triangles. So 1, 2, 3, 4, 5, 6. So in order for them to be equilateral, though, they have to be the same. They have to have the same length from the edge of the circle. So now that I have this length, I know that my lengths here and here and here and here, all the way around the circle, have to also be this length. So I can start anywhere on the circle. I'm going to start right here, and I'm going to say, look, there's my first equilateral length. Here's my second. Here's my third. Here's my 4th, 5th, and 6th. And then if I want to make sure that I was really, really accurate, which is always a nice check, I would put my pencil here. Ooh, I was not really, really accurate. So let's try that one more time. I'm going to erase my pencil marks, which this happens with construction. And part of the issue is that your pencil needs to be pretty sharp, and right now my pencil is a little dull. Also, your measuring of the circle. So if I measure this circle, it looks like I may be a little too big than the circle. So I'm going to try to adjust this just a little bit. This may be a little more precise. So I'll start again. I'm going to any point on the circle, make an arc. From that arc, make another arc. From that arc, make another arc. That arc, fourth arc, fifth arc, sixth arc. And let's measure and let's really hope, oh, this is definitely more precise than the previous one. So, you know, with construction, you kind of have to go back and forth with double checking that what you're getting actually, you know, not only is it accurate by the marks you've made, but it actually kind of looks accurate. So now I am going to connect each of the places where the arcs hit the side of the circle. I've got one side of my hexagon, two sides of my hexagon, three sides, four sides, five, and six. And then because this was a regular hexagon, I can go back and I can mark and I can say, hey, look, all six sides are congruent and all six angles are congruent. And this indicates to my teacher that I understand what it means to be regular. And that even if my picture is not exact picture perfect, those markings tell them that that's what I was going for. It's the marks these marks are the marks that tell what it is. Otherwise, it's just a hexagon. So in order to be a regular hexagon, you have to mark it as congruent sides and congruent angles. Our next and last construction for this set is to construct a perpendicular line through a given point. So remember, perpendicular means 90 degrees. So I want to go through this point and I want to be 90 degrees. So I want to look something like this, but I got to construct it. So if you can imagine that I have right up here the top part of a, take a guess, rhombus, and that then I can mark it so that I get two other sides, two other corners, vertices of the rhombus, and then the fourth one being down here. Can you see that rhombus? So what I'm going to do is I'm going to make a rhombus. I haven't been given a length, so I'm going to create any length. I'll open my compass until it hits my line segment. So now I've got 1, 2. So now I've got the first vertice, the second, the third. So to get to the fourth, I have to go make my marks below. I now have a rhombus. Isn't it amazing how many rhombuses we're constructing just with different starting points? So again, I'm going to draw in that rhombus very lightly with my pencil so that we can see it, because I think seeing that that's what I've constructed is often very, very helpful. So I have constructed a rhombus. But the part of this rhombus that I actually care about is the diagonal, because that gets me 90 degrees. So I draw in my diagonal, and I mark it as 90 degrees. I want to be very clear about something here. The length from this vertex to the middle of the diagonals is the same from the middle of the diagonals to this vertex. But I want you to notice that our original line segment is longer than that, so that this line that we drew, this second diagonal, is not a perpendicular bisector of the line segment. It is simply a perpendicular. Okay,